last class we were discussing about the fast FFT, right? So before that, I thought, let's have an intervention and let us see a few of the numericals which you have to solve. So between the FFT topic, the fast Fourier transform, and whatever I have completed in between, I want to give a small assignment on the numerical. I will have a detailed discussion on what is the approach. Then I will give you that task, homework, assignment, whatever you call it. And then what we'll do is we will see the linear filtering of long duration sequence, a very interesting topic. And all these things will give you enough reasons for to have a something called a fast Fourier transform, and then we'll go at it. Okay. So I have prepared few numericals because as the class is not interactive enough, I thought to give it as a homework to you. So let us see. As in the previous class also, it so happened that the numericals which they looked so scary, but they were all very intuitive and based on the class which I had covered previously. So most of the numericals in DFT, they are not a donkey work sort of thing, but they need some sort of common sense so that you can do things very cleverly. Okay. So we will see which are all the numericals. So here is the first one. Okay. So what is the question here, by the way? The question is perform linear convolution of sequences. Two sequences are given, you can see. Length of the first sequence is 3. Okay. Let me call it as L1. Length of the second sequence is 2. Length of the first sequence is 3. Length of the second sequence is 2. Using circular convolution. See, what I want you to do, I want you to perform linear convolution, but I want you to use the circular convolution property of DFT. Okay, what is that circular convolution property of DFT? Shall we see what is that circular convolution property of DFT? Here is the circular convolution. What does the property say? It says the multiplication in the frequency domain results in not linear convolution but circular convolution in the time domain. Okay. So what usually, if at all you take the DFT of first sequence and second sequence, you multiply, take the inverse, what you get is circular convolution. Here what I want is linear convolution. Actually linear convolution, once again let me tell you, it is nothing but filtering, what we call in general. Okay. So what is the approach? How do you do it? In the previous class, again, in the previous class, we had seen what was that thing? Yeah, linear convolution and circular convolution. I was telling you how they are related, right? So you can see here, let me try to convince you. You can see this is a linear convolution problem. Okay. So there is no limit on the length. Here is a circular convolution. So what do we see in the circular convolution is after n, say 1, 2, 3, 4, this is n. After n, if at all I overlap these final values, the values after n here, I will get circular convolution. Or otherwise, if at all I want to use DFT, that means if at all I want to perform circular convolution, but I want my result as that of linear convolution, what should I do is, as I was telling you in the previous example, when I took a 4-point DFT, all the values after 4, they were overlapping, spoiling the party. When I take a 5-point DFT, all the values after 5, they were overlapping, right? So if at all I do circular convolution, but say if at all I take n is equal to length of the first sequence plus length of the second sequence minus 1. Okay, then what's going to happen is your circular convolution method is going to give you the answer same as that of linear convolution. Okay, so now here is the numerical. Somebody please tell me what should be the length of n. I want to perform circular convolution, but my answer should be that of linear convolution. What should be the length of my n now? What should be my n? Can you tell me? The length of the first sequence is 3. The length of the second sequence is 2. What should be my length? N. How many point DFT, how many point IDFT should I take? Can anybody tell me? You can use the mic. I have allowed you to unmute. Can somebody tell me? What is it? It's 4. Very good. Okay. Yeah, the new guy, right? Welcome. So it is 4. So what should I do? What is the method, by the way? So what is the method? N is equal to 4. I should take 4-point DFT x of k. Remember, X of k can be a 4-point DFT, it can be 8-point DFT, it can be 1024-point DFT also. But then here I am not interested in the resolution in the frequency domain, the magnitude or phase. I simply want to do linear convolution, but I want to use the DFT IDFT method. Okay, so that's why I am interested in taking only 4-point DFT of the first sequence, then I will multiply it with 4-point DFT of the second sequence. N has to be same, otherwise vector size doesn't match. 4-point DFT of second sequence. Okay, I do multiply them, then afterwards I will do, after getting this I will take a 4-point IDFT. Okay, I will take 4-point IDFT. Bingo. So when I do that, I will get my answer as same as that of linear convolution. Okay. So this is the first numerical. I think now I have explained you enough. Maybe you can give it a try. Okay, got the method. So 4-point DFT of first sequence, 4-point DFT of second sequence, multiply, take 4-point IDFT, and you can cross verify it by doing the normal linear convolution. Okay. So that is the first numerical. Are you clear on this? Maybe you can try these things. Okay, so all the homeworks whatever I give, they come with a validity of 1 day. You solve them that day itself, then and there it will add value to the next class. Okay, otherwise they don't work. Okay, I usually give some lot of time to solve them, but they should be done then and there. Okay, here is a second numerical. They have given an x of n. They want you to draw x of n minus 2. Not draw, who will draw these things? Okay, maybe you can write a sequence. So can anybody tell me what is x of n minus 2? Circular. 8 this is. Okay, poor handwriting. This is 8. Okay, 1 2 3 4 5 6 7 8. N is equal to 8. Two things he wants us to do. First thing, he wants us to tell us what is x of n minus 2. So can you tell what is x of n minus 2? Okay, so it's a homework. All the numericals are a homework. Okay, but you have to solve, building from the topics. Make mistakes. Okay, make mistakes, fine. And that's how it works. Once you solve it for yourself, so maybe you'll understand things better. Okay. Okay, yeah, I have put in the previous session, I had put one a solved one also. Pen and paper. Okay, yes. Now can anybody tell me, what is x of n minus 2? It's a rotation, as I told, it's a rotation. So x of n minus 2 will have what will be the first term in x of n minus 2? Can you tell at least the first term in x of n minus 2? Can you tell me the first term in x of n minus 2? This 0 is going to move here, this 1 is going to move here, 2 is going to come here. Maybe the first term that is going to come is, what is the first term that's going to come? The values kept moving. First term is 2. No. The first term is x of n minus 2. I think it is 6. First there will be a 6. This is n minus 2. The values move toward the right side. Okay, yeah. 6, yes, good. 6, 7, then 0, 1, 2, 3, 4, and a 5. 2, 3, 4, and a 5. Okay. Okay. Second thing is interesting. Okay, yeah, this is okay, you have done this thing. Then he wants us to find a DFT. Find if DFT. See here, this is not a, once again, this is a clever problem. What is he asking is, if DFT of x of n is say x of k, you don't have to find the DFT here. You don't have to find the DFT. He is asking, if DFT of x of n is x of k, what is the DFT of x of n minus 2? That's what he is asking. He doesn't want you to find the DFT. He just wants to know what will be the DFT of x of n minus 2. So can anybody tell me what will be the DFT of x of n minus 2? Which property? Shift in the time domain, a circular shift in the time domain. See, x of n minus 2. So the DFT, corresponding DFT, is nothing but x of k itself multiplied by the term. What is the term? E to the power minus j 2 pi divided by n into k into, in place of L there shall be a 2. That's that. Okay. Cool. Okay. So that will be the thing. Okay. That's the second numerical. Anyway, you have to write it. Okay. Yes. Now here is a question. Here is a question. What is this thing? X of n is given. DFT pair is given. Now author wants us to determine what is the sequence y of n. This sequence y of n, by the way, says is IDFT of this y of n is IDFT of this x of k multiplied by an exponential. So can you guess what is x of n? Y of n, it's x of k. See, this x of n and x of k are a DFT pair. If x of k gets multiplied by an exponential, what happens to y of n? If the frequency domain gets multiplied by an exponential, what happens in the time domain? What happens in the time domain? Anybody? Anybody? If frequency domain gets multiplied by an exponential, what happens in time domain? Same thing as previously we told, right? Hmm? Same thing as we told previously. So can anybody tell the answer? Same property. Shift in the time domain is multiplying by multiplication by an exponential in the frequency domain. So can anybody guess what is y of n? Can anybody tell me what is y of n? Can anybody tell me what is y of n? Somebody, please be a sport. Hmm? Can anybody tell me what is y of n? What is the shifting factor? What is the shifting factor? Can anybody tell what is the shifting factor? See, this is a very straightforward thing. Okay, you do not get these kind of things in exam. Everything is split. Yeah. What is the shifting factor? Yes, some answer came. It is 2, right? The thing is shifted by factor 2. So what you have to do? So this y of n is nothing but x of n minus 2, circular. So this is y of x of n minus 2. You just have to solve and write this particular thing. Okay. Simple one anyway. Okay. Next, what is this? Okay. Now there is one more. Given x of n, he wants us to find y of n. What is this y of n? It is the IDFT of y of n is IDFT of y of k, which is x of k shifted by certain factor. This y of k is x of k shifted by certain factor. So can you guess, by the way, what is y of n? Shift in the time domain was multiplication by an exponential in the frequency domain. Shift in the frequency domain is multiplication by an exponential in the time domain. But there is a small catch. Okay, the minus is missing. See here, minus and minus. Here there is a minus. Here there is a plus. Okay, got this particular thing. So what you have to do is, you should do this particular thing. So can anybody tell me what is the value of L here? I think the value of L is nothing but whatever that's minus. I think it's 2 only, right? I think it is shift in the time domain is multiplication by an exponential in the frequency domain. So L, I think, is 2. But how do you find the values, by the way? How do you find the values? So what you have to do is, the expression is e to the power j 2 pi by 4, e to the power j 2 pi by 4 into 2 into n. Okay. So for finding the first value, what you have to do? Multiplied by x of n. To find the first value, you have to multiply 1 by this particular factor. Here you have to substitute n is equal to 1. For this value, you have to substitute, for the first value, substitute n is equal to 1. Then substitute n equal to 0, 1, 2, and 3. Okay, 0, 1, 2, 3. You have to substitute. You should get an array. Then you have to multiply element by element. Interesting. Okay, give it a try. Got this? Got this? Okay. Yes. Now, here is one more. Here is one more. What is this thing? Sorry for those. I try to make it better. Finding energy of a 4-point sequence. Okay. Can you tell me what is this sequence? For n is equal to 4. For n is equal to 4, can you tell me what the sequence is? The sequence is going to contain only 4 values. Let me tell you. I will tell the easier one. That's what I do usually. Let me tell you the easier one. For n equal to 0, sign 0 is 0. There you go. First value, I told. First value is 0. Sign 0 is 0. Can you tell me what is the next value? For n is equal to 1. This n shall be substituted as 4. We should get values from 0 to 3. Okay. So can you tell me what is the value here? Somebody? please. For n is equal to, what's the value? 2 pi divided by 4 into 1, that is 2 pi by 4. 2 pi by 4 is pi by 2. What is sine pi by 2? Hmm? Anybody? Anybody? Yes, the answer is simple, but somebody has to tell it, right? Somebody has to tell it also. So will anybody tell me what is the value? What is the value? What is the value? The value is 1. Okay. The value is 1. I think there is some shaming going on to those students who answer, right? Okay, there is a shaming going on for those students who intend to answer. It's a very bad practice. Okay, it's very bad practice. It's like, you're pulling the morale of the entire batch down, and okay, it's not good also. Okay. Okay, anyway, right answer. Next, for n equal to 2, anybody? For n equal to 2, can you tell me? For n equal to 2, 2 pi divided by 4 into 2, that is sine pi. What is sine pi? Sine pi is confusing. What is sine pi? Anybody? Anybody? Sine pi. What's the number? Okay, okay. 0. Then n equal to 3. 2 pi divided by 4 into 3. 2 pi divided by pi by 2 into 3. What's the number? What's the number? What's the number? What's the number? Somebody? Somebody? Your friends are answering. Okay, your friends are answering. They are getting bored for not getting answers. So everybody can participate. Everybody can participate. Okay, so I will give it to you. This one. Let me keep this thing blank. Okay, okay. By the way, what is this thing? By the way, what is the question? How do you find the energy? What is the formula for energy? Anybody? Anybody? You can use mic. I have allowed you to unmute. Okay. Writing answers is, I understand, difficult. Can anybody tell me how do you find the answer? What is the energy of a sequence? Suppose I have sequence 1, 2, 3. What is the energy of sequence 1, 2, 3? If at all I have sequence 1, 2, 3, what is the energy of sequence 1, 2, 3? Anybody? Do you know? Anybody know what is the energy of sequence 1, 2, 3? Does anybody know the energy of sequence 1, 2, 3? Anybody? What is the energy of sequence 1, 2, 3? Do you happen to know? Anybody? Energy of sequence 1, 2, 3. I'm just asking, I'm just checking. Energy of sequence 1, 2, 3. Does anybody know? What is the formula to find the energy? How to find the energy? So I'm asking energy of sequence. Suppose I have sequence x of n is equal to 1, 2, and 3. What is the energy of sequence 1, 2, 3? It is going to be, you don't know the formula for energy? Signals and systems. Formula for energy. How do you find energy? Somebody. Should I ask them? Should I ask you guys, by the way? Who is it? Far, do you know what is the expression for energy? Does anybody know? Zurek, do you know the expression for energy? Do you know the expression for energy? Irbas, do you know expression for energy? How do you find energy? Energy of a sequence, discrete time sequence. Energy of discrete time sequence. How do you do this? Squared sum. 1 square plus 2 square plus 3 square. 3 square is 9. 9 plus 4 plus 1, 15. Okay, that's how you find the energy. Very easy. Squared summation. Okay, energy is found by squared summation. It's time to revisit your S&S book. It's the common sense. Okay. So energy is squared sum. 1 square plus 2 square plus 3 square. Similarly, here you had this sequence. Your friends told me the thing 0. Right, the sequence we determined using time domain approach, but using frequency domain approach. What is this frequency domain approach? Frequency domain approach is this thing, the Parseval's theorem. There is a corollary of Parseval's theorem. So what you have to do is, in this particular formula, first you have to find, see, I had shown you the special case of a Parseval's theorem, right? Yeah, this one. This special case is what is usually used. So what you have to do is, you have to find the DFT of the sequence, 4-point DFT. Then afterwards you have to do the squared summation and then divide it by 4. Just cross verify. both the things, are they giving same values or not? A simple problem, okay, a simple problem. But the Parseval's theorem is into, so you have to quote the Parseval's theorem, then you have to quote the corollary where y of n is x of n. By the way, can anybody tell me what is the squared sum of 3 plus 2j? What is magnitude of 3 plus 2j? Can anybody tell me what is magnitude square of 3 plus 2j? Can you tell me what is magnitude? Okay, okay, let me keep it simple. Wait a second. 1 plus j. Can anybody tell me what is the magnitude square of 1 plus j? Can anybody tell me what is magnitude square of 1 plus j? It's tricky, okay. So when you want to do find the magnitude of 1 plus j whole square, what you have to do it? You have to multiply x of k with its conjugate. Otherwise, what's going to happen is j into j becomes minus 1 and you'll get a wrong answer. Okay, so that's why this is absolute whole square or the magnitude thing. Okay, do not get confused. Okay, just cross verify. So it's this numerical is based on a Parseval's theorem. Okay. Yes. Then there are a few interesting ones. Endpoint DFT of delta n. Delta n is the impulse. Then that of a step. Then there is that of an exponential. This is easy. For these things, a general formula I want. Okay. A general formula. A general formula is solved by simply substituting in the general numericals are solved by substituting in the general formula only, and you simply arrive to an extent where you can stop. Okay, do not go creepy. Okay, just give them a try. These two templates. Okay, these two templates, I want them to be represented and I am expecting an answer. Let us see if at all you can make any guesses. Can you guess, by the way, what is the DTFT of delta n? So what's going to happen? What is the expression for x of n? See, remember the question is delta n. Okay, let us see what is the expression of x of n. Do you know expression for x of n? DFT, sorry, expression for DFT. Let me take you here. Okay, uh, yes. Why I am doing this? I could have written the question there, right? Okay. Okay, so there is the expression for DFT. Okay, sorry for being dragged there. There is the expression for DFT. If I say x of n equal to delta n, if I say x of n equal to delta n, then what will be the answer? What will be the answer? Now see here, how are you going to do this? See, delta n means what is the value at n equal to 0? Can you write x of n equal to delta n, say for n equal to 0? Can you tell me the sequence? What will be the value at 0 for delta n? Can anybody tell me what will be the value of delta n at n equal to 0? What will be the value of delta n at n equal to 0? Anybody? Value of delta n at n equal to 0. Value of delta n at n equal to 0. It's an impulse. So at 0, the value is going to be very good. The value is going to be 1. At 1, can you tell me what will be the value? At 1, can you tell me what will be the value? At 1, the value is 0. Okay. At 0, it is 1, and all the places it is 0. And all the places it is 0. Now, see these expressions here. See these expressions here. You are supposed to solve it cleverly, but I've just thought, So, it's only going to contain, what is this particular term? This is always 1. This is always 1. And all these terms, gone, right? No. Because x of 1, 2, 3 and all are zeros only. So what do you think you will get? What will be the answer of DFT for delta n? Can you guess what will be the answer of DFT for delta n? Can you guess what will be the answer of DFT for delta n? This term won't be there. These terms won't be there. These terms won't be there. These terms won't be there. This w to the power 0. This is 1. This is also 1. This is also 1. X of 0 is 1, 0 is 1, 0 is 1. So can you tell me? Can anybody tell me what will be the endpoint DFT of delta n? What will be endpoint DFT of delta n? Endpoint DFT of delta n. Can anybody tell me endpoint DFT of delta n? So we are expecting an answer, something like what? Anybody? Delta n. It's going to be 1 from 0 to what is it? K. 0 to n minus 1. It's going to be 1 from 0 to n. What's going to happen after n? It's the same thing, right? DFT is periodic. Okay. What this particular thing? It's a template. Okay. Be curious and solve this particular thing. What about x of n equal to u of n? What's going to happen for x of n equal to u of n? What is x of n equal to u of n? What is the value at n equal to 0 for u of n? What is the value at n equal to 0? What is the value at n equal to 0? For x of n equal to u of n, it's a step. What will be the value at n equal to 0 for u of n? For step, what will be the value at n equal to 0? Anybody? Anybody? Oh, thank you. It's 1. For n equal to 1, it is 1. For n equal to 2, it is 1. For n equal to n minus 1, it is again 1. From 0 to n minus 1, all the values are going to be 1. Very good. Okay. So, what's going to happen to the DFT? What's going to happen to the DFT then? Shall we go to that expression only and try to evaluate? What's going to happen to DFT? As I was telling you, the DFT and time domain, they are a dual. Okay. Impulse in time domain. Did you see that thing? Impulse in time domain. Impulse in time domain. Yes. Anything? Yeah. Everybody say hi. Everybody say. That's why we are all here for. I will just say hi. Yeah. Yes. Okay. Now see, DFT and time domain, they are a dual. Okay. Just now we saw an impulse in time domain was a step in frequency domain. So a step in time domain is expected to be an impulse in frequency domain. Okay. A step in time domain is expected to be an impulse in frequency domain. Okay. I have just given you a hint. Give it a try. Give it a try. Then this is based on a template. Here, see, it's a cos wave. So for a cos wave, I am expecting an impulse at k naught and minus k naught. Okay. Something in terms of delta I am expecting. Okay. Because you have done this thing in DTFT, right? So something similar in DFT also. For a sine wave, for a change, you will get something like this, right? A positive impulse on the left side, a negative impulse on the right side. Okay. Something like this. Delta n minus n naught. See, for delta n it is something. A shift in the time domain is a multiplication in the frequency domain. So just have to multiply your answer, whatever. What did you get by the 1, right? You have to multiply it with e to the power minus j 2 pi by n into n naught. Okay. You have to multiply. Okay. So that's that. What next? Yeah. Here is an interesting one. Here is an interesting one. What is that? High only. Okay. So here is an interesting one. What is this? See here. For the sequence, find 10-point DFT. 10-point DFT sounds very scary. Okay. So you cannot use the matrix method. But since the sequence x of n contains only 2 terms, I think we can use the ready formula. We can use the ready formula. Okay. Where we substitute n equal to 10. And there is a clever method of solving this. You can see here, DFT is linear. Okay, DFT is linear. DFT of delta n is all ones. DFT of 10-point DFT of delta n is 10 ones you will get. So you have to take this particular sequence. Then you have to add it with, right? I told you DFT is linear. A plus remains a plus. So see here, delta n minus 5. So this particular sequence itself you have to take separately. You have to multiply it e to the power minus j 2 pi divided by 10 into 2 pi divided by 10. Oh, I can't write it. I will quote it. Okay. Into 5 into n. Okay. Then you have to substitute n equal to 0, n equal to 1, n equal to 2, and so on. Okay. So this is a clever way of doing it. Otherwise, I think you can directly do this 10 values, right? Only 2 values. So you can use the formula. But I would suggest that you use the linearity and the time shift property. So this numerical uses linearity by taking delta n and then the time shift property. Okay. Then there is one more. Find the DFT sequence that has a 10-point DFT. So whatever sequence you get, right, when you get the DFT x of k, you know x of n. Okay. So if at all the DFT gets multiplied by exponential x of n, whatever sequence you had. What is the sequence, by the way? This is 1 0 0 0 0 the n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, then a 2, then again zeros. Okay, that is the sequence. So multiplication by an exponential is going to result in shifts. Okay, so this one will come here, I think. So here on left side you will get zeros. Give it a try. Give it a try. Then there is one more. What do they say? If this x of k, whatever I got in the beginning, okay, x of k is the DFT of this x of n, whatever I get. If that gets multiplied, if that gets multiplied by w of k, where w of k is DFT of this particular sequence, what's going to be x of n, y of n? They are asking. What's going to y of n? So what I have to do? You see here, this also this is not at all a scary question. He is not asking you to find w of k. Okay, he's only asking you to find the IDFT of y of k, which is y of n. So what you have to do is, see here, this is multiplication, right? Multiplication in DFT is circular convolution in time domain. So what you have to do is, you have to perform 10-point circular convolution of this particular sequence. What is the sequence? 1 0 0 0 2 0 0 0 with, what is the sequence? This is 1 1 1 1 1 1, then remaining zeros stuffed in zeros. Okay, that's what you have to do. Interesting one. Interesting one. Give it a try. Okay, interesting one. Give it a try. Okay. Then here is one more. So what is it? 8-point DFT it seems. Okay, some 8-point DFT of a real sequence. So they have given 5 points. They want you to find the remaining 3. How do you do this? We know this thing, right? The first value, this value, x of k equal to x of n minus k. This value and the last value will be going to be complex conjugate. So this is 0.5 minus j 0.5. This is going to be 0.5 plus j 0.5. Okay, and once again, if this is going to be 0, this value will also be 0. If this is going to be 0.5 minus j 0.86, this value is going to be minus 0.5 plus 0.86. Okay, give it a try. Give it a try. I will give you a detailed assignment. Okay, I will give you assignment. Who are supposed to write which one? Okay, so now in the next class, we will discuss, in the next class to come, we will discuss this particular thing. What is this? Linear filtering using DFT. What is linear filtering? Linear convolution using DFT. Okay, you already know. How do we do this? Can you perform linear convolution using DFT? Yes, we do. How do you do that? Only thing is, you have to do circular convolution, and the only thing is, you have to take the point. Circular convolution is length of the first sequence plus length of the second sequence minus 1. Okay, so we saw that earlier problem. Length of the first sequence 3, length of the second sequence was 2. So we took a 4-point DFT, multiplied, took 4-point IDFT. We got the answer as that of linear convolution. If at all we had done 3 points for both of them, we would have got circular convolution. We would have not got linear convolution. So it is true that linear filtering can be done using DFT. But what if the duration is very long? Say, if at all I am telling you something here, my audio typically contains, if at all it's an MP3 quality, 16,000 samples per second. 16,000 samples in 1 second. But my length of my impulse response is going to be only 4th order filter means 4, 60th order filter means 60. So it poses a very interesting problem, maybe in next class. Okay, thanks for joining. Do that assignments, whatever that are pending this weekend only. Okay, let's meet. Bye.